Welcome to lesson 4 of univariate data or statistics. Here we cover measure of central tendency, which is the mean, median and mode, and we cover measure of the spread, range and interquartile range. The presentation is divided into part A and B. We'll start off with part A covering theory and with some worked examples. So when do we use mean, median or mode? Well, the median can be used for any numerical data, but is well suited for data with outliers. And that is because the median is not influenced by extreme values. An example being, say, house prices in a suburb. If most of the prices are around a particular value, and then we have one particularly high valued house, then the median value doesn't tend to get impacted by that outlier or that high price. Mean, we also often know as the average. It's to be used on numerical data that does not have outliers. And that's because it gets greatly influenced if there are outliers present. And finally, the mode is the most commonly used for categorical data or discrete numerical data. That's the value that appears the most. An example being that most people barracking for a particular team, or most people have two siblings in their family. So let's go on and look at the definitions. The first one being we're going to define is the mean. We also might know it as the average number. The mean is equal to, and we go straight to the right there, the sum of all scores, or we could sum of all values, divided by the number of scores, or the number of all the values. In the middle there, we've used mathematical terminology. That top line, numerator, is the sum of x, shorthand for the sum of all the values or scores, and the n represents the number of scores or number of values there in the denominator. So the median, which is our middle number, and to find our middle number, we first have to take the data set and put them in order from smallest to largest. And it does depend on the number of scores. So we use this formula n plus 1 divided by 2 to find out which is our middle score. So if we have 11 values or 11 number of scores, we then have 11 plus 1 makes 12 divided by 2. 12 divided by 2 is 6. So we know the median or the middle number will be the 6th score in the sequence. And alternatively, we could have an even number of scores. Say we had 12 scores, then, or 12 pieces of data. 12 plus 1 divided by 2, that's 13 divided by 2, comes out as 6.5. So it's telling us the middle value or the median value sits between the 6th and the 7th value. So we have to go and find those 6th and 7th, see what their values are, and then average to define what the middle value would represent. And finally, we've got the mode. Well, that's the one that occurs the most common value in the data set, and that may well be more than one. So we might find the 5th value and the 13th value. Take a couple of examples. They might both occur 3 times, so there'll be more than one mode. All right, let's have a look at this worked example. So here we've been given a data set of 5, 8, 3, 4, 2, 7, 4, 5, 9, 9, 6 and 10. You'll notice there, they're not in order to begin with. So we'll look at that in a moment. So the first thing to work out is the mean. And what we do is we take all those numbers and we add them together. So it's the sum of all the values there in the numerator. And we divide it by the number of pieces of data or number of values. And we see there's 12 pieces of data. So we divide it by 12 there in the denominator. And we find the answer comes out to be 6. So 6 is the mean value when we do that calculation. So the next one to do will be the median. And what we have to do here first is we have to put all the numbers from the data set in order. First one, the lowest value is 2. We work our way up to the highest value being 10. And the thing we have to recognize, and we'll just bring up the next slide, or next click on the slide here, that in fact, because we have an even number of pieces of data in the data set, being 12, we have to say to ourselves, where will we find the median value? So I've written there in red, n plus 1 divided by 2, n being our number of pieces of data, which is 12. So we've got 12 plus 1 divided by 2 comes out to be 6.5. It tells us that the middle value must be the average between the 6th and 7th value. So our 6th value is 5, our 6th value is 6. So as I've written there just on the right in black, 5 plus 6 divided by 2 gives us 5.5. So we've found the average value that sits between the 5th and 6th value. In this case, it's 5.5. And finally, the mode. Well, in this situation, this data set, we see that the number appears, 4 appears twice, the number 5 appears twice, and the number 9 appears twice. So they are of equal, I guess, from a mode perspective, because they're all occurring the most number of times, which is twice. So let's have a look of defining what the range is, and the range is the largest value take away the smallest value. So a fairly straightforward calculation for range. Interquartile range, a little bit more complex. We're going to see what that relates to graphically in a minute, but it's the third quartile minus the first quartile. And that means it grabs, or it's a range, if you like, of the middle 50% of the data. We'll look at that in a bit more detail in the next slide. So let's have a look. This is really perhaps a graphical way of laying out using a football game which has 4 quarters to give you the concept of how the quartiles fit in. So we might say the very start of the game where we have 0% played, that's our minimum. Likewise at the very end, the maximum, end of the game, we've done 100% of the game. So, and we could equate that to being the minimum being 0 minutes perhaps, and the maximum up the other end perhaps being something like, might be 100 minutes. So that would then mean the second quartile, or Q2, which sits right in the middle, we call that a median, or the half time period at 50, that contains, we're at the 50% mark. To the left, we've got quarter time, 25% of the data's been covered, or 25% of the time been covered, and we call that Q1. Likewise, on the other side of the median, we find the third quartile, or Q3. We align that with 3/4 time in a game of football or soccer or whatever it might be. So we're going to see an example shortly where we can see these sort of calculated out. All right. So how do we find the lower quartile and the upper quartile? Let's see what we can do. First of all, we're going to write the data in order from lowest to highest. Then the next step is we find the median of the data. So if you think back to what we did before with those 12 pieces of data in the previous slide, we get them in order, step 1. Step 2, we start finding the median. I think there we found it to be between the 5th and 6th value, I think it was, or 6th and 7th rather, and it was 5.5. So then step 3 will be, we're going to look at the lower half of the data, which is to the left of the median, and we look to find the middle value of that lower half. So what occurs in the lower 50%, we find that middle value, and that's our lower quartile Q1. And in the same way, for the upper half of the data, which is to the right of median, we find the middle value of this upper half. We're going to call that the upper quartile. So stay tuned for the next slide where we'll start to see it sort of play out a bit more clearly. Oh, just before we do, we go on, we see there so then once we've found Q3 and Q1 from our step 3 and 4 above, we can take away Q3 minus Q1, and that gives us the interquartile range, which is sometimes shortened to IQR, and that is effectively representing what's contained in the middle 50%, the middle 50% of data. And we see how wide it is by this IQR. So here we're going to look at 2 worked examples. So let's do the first one on the left to begin with. I'm just going to lay out the animations down here just so they're all laid out to begin with. So just looking at the left hand side, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 pieces of data. That's what I said, it's an odd number pieces of data. So there's 9, that makes the fifth value is our median, or Q2, number 5. Then we've got to look at the bottom half of the data, which includes numbers 1, 2, 2, and 3. So given there's 4 pieces of data in that bottom half, then the median in the bottom half sits between the second and the third value, which is the average of 2 and 2 in this instance. Average of 2 and 2 is 2, so we say the Q1 is 2. And then likewise for the upper 4 values, 6, 6, 7, and 9, again there's 4 values, so the median value, the middle value of those 4 will sit between the, let me see, the 7th and 8th value, which is the 6 and the 7. The average of 6 and 7 is 6.5, so Q3 is 6.5. So just using that formula at the bottom we saw on the previous slide, Q3 minus Q1, in this instance for the left-hand example, would be 6.5 minus 2, and that gives us 4.5, an IQR of 4.5. All right, so let's look at on the right-hand side, where there's an uneven number of pieces of data. I think we have 10. So if we've got 10, then we know that the middle value, because it's an even number of data, the middle value is going to be at 10 plus 1 divided by 2, which is at 5.5, the fifth and a half value, or between the fifth and sixth value. And we see here that's between 7 and 8. The average of that is 7.5. So that's our Q2, the median value. The bottom half of values, which contains 2, 3, 3, 4, and 7, 5 pieces of data. The middle data is the third value along there, which is number 3, so Q1's 3. And in the top half, again, we've got 5 bits of data, 88999. We can see there that the 8th piece of data, which is the middle of that top half, is the number 9, so Q3 is 9. And we say Q3 minus Q1 to get our IQR will be 9 minus 3, gives an IQR of 6. This brings us to part B of the presentation. It contains student questions followed by answers on the next slide. So please go ahead and slowly work your way through these questions. I encourage you to work on the question first to your best ability before clicking on to the next slide where the answers, and you can self-mark your results.